Our next problem that we're going to solve is finding side lengths using sine, cos, and tan. Look at this. So, sine, opposite over hypotenuse. Ka, cosine, adjacent over hypotenuse. Toa, tangent, opposite over adjacent. We're going to use one of those trig ratios to solve for this missing side length. Because we have a right triangle and we know one of the two acute angles, we'll be able to solve it. We solved it similarly in the format. So in this particular problem, we're going to utilize this 52-degree angle and ask ourselves, what are we looking for and what do we have? Well, we're looking for the opposite side and we have the adjacent. Here's the 52. If we're going to use that 52-degree angle, we're looking for the opposite and we have the adjacent. Opposite, adjacent, tan. So here's how we're going to do it. We're going to go tan, 52-degree angle. Now the tan of a 52-degree angle is in your calculator. It's going to be a decimal, but you don't need to take it out of your calculator to help solve this equation. Okay, we're going to leave it just like that. And then on the other side, the tan of the 52 in this problem is going to be x over 12. There's our equation that we're going to solve. Now in a problem like this, think of it as a proportion where you're going to cross multiply. And you're going to take the 12 times the tan 52. So in your calculator, you're going to do 12, right? Again, those are two numbers, I understand. Times, right? Multiplication problem. Tan 52. Again, those would be two buttons, but I think we understand. 12 times tan 52, and then we're going to hit enter, and a number's going to pop up. And the number that's going to pop up is this particular side length. I believe that number is going to be, we'll round to the nearest tenth, is going to be 15.4. So that side length right there is 15.4. And again, we use tan because we were looking for the opposite and knew the adjacent. I didn't use so or ka because I didn't know the hypotenuse. Let's use the same triangle, change the given a little bit. And why don't we do it this way? We'll even use the 52 degrees there. And we're going to give that as the 12. And we're going to look for the hypotenuse. So that changes things a little bit. Same triangle, same 12, but in this problem we're looking for the hypotenuse. So there's the 52-degree angle. The side that we have is adjacent to it. We're looking for the hypotenuse. Adjacent, hypotenuse, adjacent, hypotenuse. We're going to use cos. The cos of a 52-degree angle, the cosine ratio, is expressed as a decimal and it's in your calculator. But we're not even going to have to take it out of our calculator. We're going to do it similarly to the problem we just did before, but because this is cosine, we're going to put the adjacent over the hypotenuse. Now this requires us to do some different calculator entries. Before, when the 12 was here, we put in 12, and that we're still going to start with the 12. Okay, I always start with the number that's on this side, whether it's numerator or denominator. But if it's in the numerator like that, you take 12 divided by, remember before it was multiplication when the 12 was down here, 12 divided by cos 52. Enter. Cos 52, enter. And if you hit cos 12 divided by cos 52, enter, you're going to get an answer where it's going to be, we're going to calculate rounded to 19.5. X is going to be 19.5. So when you're finding side lengths, you have two basic setups. You have the one where the number that you know, the side length that you know, is in the numerator. Okay, you still set this up same way, but the number's in the numerator. If it's in the numerator, you're going to do 12 divided by, and enter whichever ratio we're using, sine, cos, or tan, the number of degrees and the angle, and hit enter. Okay. The other kind of problem, the other setup that we're going to have was when the 12 was in the denominator, excuse me. And that problem said 12 times. 12 is down here. Think of it as cross multiplying. Otherwise, when it's on top, you start with the 12 divided by cos 52, enter. And that will help you find a side length when the number that you know about is in the numerator.